Okay, so as in the last video, we discussed about Fazan'S rule, right? We were talking about covalent characters in the ionic bond. We said this is a qualitative rule, which means we cannot identify how much we have covalent characters in it, but we can compare an ionic uh, compound with an other ionic compound. We can compare and we can then identify which one has more covalent characters and which one has more ionic characters. Then we discussed about polarization power and polarization, right? So anion will have polarization, anion will have polarization, while cation will have polarizing power. Now what does mean by polarization and what does mean by polarizing power? Polarizing power means it will gonna it will make anion attract towards it, which means what it will do, it will it will it will make anion to make towards it, right? It will gonna make anion towards it. And polarization means it will be attracted towards cation, right? So polarization means it will be attracted towards cation. Polarizing power means it will polarize anion, and anion will be polarized, which means it will be attracted towards cation, right? Now in today's video we are going to study some conditions of cation. Initially we'll study the conditions with respect to cation first, and then we will be discussing about anion conditions, right? As we know that cation will have polarizing power, right? Which means the more polarizing power there would be in the cation, the more characters there would be of the covalent, right? If there would be polarizing power more, right? Polarizing power more, which means covalent characters more, right? Which means ionic bond less. Okay, so now when this polarizing power will be more, we need to talk about this now. Okay, initially we are going to learn the size of cation. Size of cation. The smaller size would be of the cation, the more polarizing power it would have. What did I say? Let me write here. Smaller size, more polarizing power. Polarizing power more. Okay. Now see, if you have this cation, positive is a positive charge, right? And if you have this cation, now see, positive charge is distributed. Here positive charge is concentrated. Here it is distributed, which means smaller the size of the cation would be, more polarizing power it would have. Which means the polarizing power of this cation would be more as compared to this. This will have less polarizing power, right? Polarizing power. So the smaller the size of the cation would be, the more polarizing power it would have, right? Now we have talked about size of the cation. Let's talk about now the charge of the cation. Charge of cation. Okay. So the more charge the cation will have, the more polarizing power it will have. So more charge, more polarizing power. More polarizing power. Okay. Okay, now let's talk about the last one, which is about pseudo Nobel configuration, pseudo Nobel gas configuration. Okay, pseudo Nobel gas configuration. An atom which will have configuration same as noble gases, for example ns2, okay, np6 or nd10. This is what, this is pseudo noble, this is noble gas configuration, right? Noble gas configuration. This is noble gas configuration. So an atom which will have this configuration would be known as pseudo noble gas configuration, and an atom which will have pseudo noble gas configuration will have covalent characters more. Okay, let's take an example now. Okay, let's take examples here. We have NaCl, okay, we have potassium chloride, KCl, and we have rubidium chloride. Now we need to identify which one will have more covalent characters. Which one have more covalent characters, right? We need to identify it. See, now we have already talked about size. So let's apply the rule of size here. Let's see the anion first. Anion in all the compounds are same. Chloride, chloride, chloride. Which means now we need to work on cation. Okay. So Na will have this size, 2 electrons, 8 electrons, and 1 electron, right? Potassium will have this size, 2, 8, again 8, then you know what, and it will have this size. Okay, now see which one has more size. This rubidium chloride has more size. Now we have already talked about size factor. The smaller the size would be, there would be more polarizing power. Okay, so rubidium has larger size, which means it has smaller polarizing power. Okay, it has moderated polarizing power, and NaCl has smaller size, which means it has more polarizing power. Now if it has more polarizing power, it will make anion attract towards it more, right? Which means are more covalent characters are more in NaCl, right? Covalent characters are more in NaCl. So NaCl has more covalent characters, KCl has less covalent characters, RBCl has less covalent characters, right? Now let's talk about charge. Okay, see, we have NaCl, we have MgCl, we have AlCl, aluminum chloride. See, we have NaCl, MgCl, aluminum chloride. Now see, Na has one positive charge, magnesium has positive 2 charge, and aluminum has positive 3 charge. Initially see the anion. Anion is same in all of these three compounds. Na, now see size factor. The more the charge there would be, the more polarizing power there would be. Na has 1, Mg has 2 double positive charge, Al has positive 3 charge, which means it has more charge. It has more charge, so it will have more polarizing power, and more polarizing power means more covalent characters. And more covalent character means less ionic bond. Ionic bond. Now do you understand how do we identify which one is more ionic and which one is more covalent? This is qualitative rule. We just compare. Now see, here we have compared, here we have compared two. We cannot identify here how much covalent characters we have. We can only see how much it has covalent characters in comparison to another covalent ionic bond. Okay, so this was all for today. In the next video we're gonna learn the conditions with respect to anion.